All right, so yesterday we were talking about how if we've got these types of, so we had to start with parallel lines. And if we have parallel lines, then we have three types of angles that have a congruency relationship. So these angles are corresponding. We have our alternate interior, and we have our alternate exterior. Those all start off if two parallel lines are cut by a transversal. Okay, then these things, corresponding angles or alternate interior angles or alternate exterior angles, you can say whichever one of those, and then you say they are congruent. Okay, if you remember same side interior angles, what were they? What was the relationship between those? They were supplementary. Okay, that was the one grouping of angles that were different, and that's the one that usually people struggle with, mainly because we'll do 4, 5, 6, 7 problems in a row that either deal with corresponding, alternate interior, or alternate exterior, and you just get in a habit of saying, okay, whenever I get this picture of parallel lines and transversal, it seems like I'm always putting these parts congruent to one another, these parts equal to each other. And you do it 5, 6, 7, 8 times, and the next one is supplementary angles. But you've trained yourself essentially in the last 7 to say that they're equal, and that's what the people usually do. Does that make sense? So you just got to be careful with that. I want to do a proof here. If you look at your notes, I know you're printing your notes out. So this was like a long time ago, the way I did this. I want to just kind of do this proof kind of systematically where it's talking about, now we never use this, and this is another idea about theorems. What we're about to prove could be a theorem. It could be something that we always use forever. It's true, no matter what. Every proof that we ever do, once we are complete with it and we prove what we set out to prove, that can be established as a theorem. But theorems are only established and written in textbooks because of their prevalence later on and how much we use them later on. Does that make sense? Okay. We're not going to use this feature later on. So these would, angle 1 here and angle 8, if we look at that, we're trying to prove that those are supplementary in this problem. And we'll be able to prove that. We will get to that conclusion. And that can become a theorem. And we could say that if two parallel lines are cut by a transversal, then same side exterior angles are supplementary. Does that make sense? Because that's what they would be. They're same side and they're exterior. But that doesn't ever get used enough later on in the course or really anywhere else in geometry or anywhere else in mathematics that it needs to become a theorem and that we put it in a textbook. Does that make sense? So there's a lot of facts out there that we can prove. Only the facts that become very useful to us are then the ones that actually become established as theorems. But nonetheless, we can still practice the process of doing a proof with these. So what I want to write is that A is parallel to B. That was my given. A parallel to B. Okay. Now what we can do is, because we've established already prior to this problem, we've established that here we had alternate interior angles were congruent, and here we had corresponding angles were congruent, and here we had alternate interior angles are congruent, and here we had same side interior angles supplementary, right? So because those are all already pre-established facts, we can use those inside this theorem or this proof. Okay, so whenever I see in a proof from here on out, from today to the end of your math careers, in a proof that uses the parallel symbol, you're going to look at your picture and start writing the congruencies that you know and anything that might be supplementary that you know. Okay. So if I look at my picture up there, what are some angles up there that you know to be relatable to one another? Ready? Okay, so angle 1 is going to be congruent to angle 5. Okay, and we had the theorem. Now, I'm not going to write this out because I should write if two parallel lines are cut by a transversal, then corresponding angles are congruent, right? You guys want to write that? No. So what I'm going to write is just corresponding, spell it right, corresponding, write the angle symbol, and then THM for theorem, corresponding angles theorem. And that then takes place of that phrase, if two parallel lines are cut by transversal, then corresponding angles are congruent. What I'm going to do next is I'm going to go to my picture, and I'm going to put those congruent symbols in my picture. Okay? So that's the idea that if we go back to that handout in chapter 2, section 6, if we were to come to, I guess it's 2.5 to start it in. These steps here, okay, those 7 steps, first one says write down the given, we did that. If there's information regarding equal and congruency signs, fill that in. We didn't have any of that right off the bat, so we skipped that step. Step 3 says look for vocabulary. Parallel was our vocabulary word, right? So then we looked at our picture and said, okay, well, what does that lead us to in regards to parallel? And it established some congruencies, right? And that's where step 4 comes in. It says, from what you learned using your vocabulary, indicate any equality or congruency statements within your picture. That's exactly what we just did when we drew those in, okay? Still looking at our picture, though, okay? Because, yes, we talked about parallel, and we came up with a fact about it, but are there other facts up there that might be true based on that? Maddie?
Like other stuff in the picture?
Yep.
7 and 8 or something.
7 and what?
8.
Okay, so I'm going to write angle 7 and angle 8 are supplementary. Okay? I know there's an urge for people when they have supplementary or they see those two in the picture that they want to jump straight to 180. They want to say 7 plus 8 equals 180. Try to fight that urge and write that they're supplementary first, and then we can write that they're supplementary or they add to 180. Okay? So this is because 7 and 8, what kind of angles are 7 and 8 as a group right now? What do they form? Form a line, right? You guys remember, so I have a pair of angles that form a line. They're referred to as a linear pair. Okay, so I'm going to say linear pair postulate. If you remember that phrase, it said if two angles form a linear pair, then they are supplementary. So I know 7 and 8 by looking at them, they form a linear pair. So the conclusion I can make from that is that they're supplementary. Now, what do you know about if they're supplementary? Going off of what we've said in the past, what can I say about those two angles? Okay, now I can say measure of 7 plus measure of 8 equals 180. Oh, that's a 4. And that's because we said up here, we introduced a vocabulary word there, and we're just going to write down then what does that vocabulary word tell us for our particular problem. So we'll say definition of that vocabulary word, which is supplementary angles. Okay, so that's good. Anything else that we know? Joel? Well, careful. That's what we want to prove. So right now, I can't stitch any of the things that I have right now together that allows me to make 1 and 8 supplementary. So there's something that's going to come before that. Connor?
We're talking about 8 and 1.
Not 8 and 1 now. Because our last step, whenever we're done, that's going to be the phrase that 1 and 8 are supplementary. So there's nothing right now that we know about 1 and 8. Anna? Angle 1 and angle 7 are congruent. We can make that. Angle 1 is congruent to angle 7. Now, did you know, so what kind of angles are 1 and 7, first of all? Alternate exterior, right? So we have the alternate exterior angles theorem. Now, here's my question. Did you need to know that like 1 and 5 were congruent before I knew 1 and 7 were congruent? Do we need to know that? No. So those two steps are referred to as being independent, okay? Meaning they're not impacted by something, right? Okay? So they can actually, those two steps can actually float around in the proof and be in different spots because they don't, right now, rely on one another or really anything else, okay? Independence of steps is something that people often struggle with because of them being able, my neighbor can write it this way, but I could write it, maybe I could flip-flop steps 2 and 5, I could flip-flop steps 2 and 3, and it just, the variations that would still be okay and validate the proof still are immense when we have independent objects. Okay, so now I'm going to put into my picture, because I set a congruency here, I'm going to fill in my picture and put a congruency there. Okay, angle 1 already had a mark in it, right? Okay, so now I go to 7 and I put a mark in there that should match to the marking that's already in angle 1. Okay, anything we can establish now? Anything that you guys want to make an argument about? 5 and 7 are congruent, okay? So that is fine. Angle 5 congruent to angle 7. What do you want to use as a reason for angle 5 and angle 7 congruent? Jagger?
There's a symbol. Whatever that thing.
In the picture?
Yeah.
Okay, so what you're saying, and kind of follow along with this, guys. If we've got a group now of 3 things that are all congruent, right? We have 3 things that are all congruent. What was the property that says if I have a bag full of things that are all the same, I can reach into that bag, pull 2 of them out, not even look at them, and know that those 2 are the same? Remember that? And it relates to this here and that there. Oh, I'm sorry. It's actually those 2 that I highlighted. If I look at those 2, and I'm going to rewrite them in a different order, I'm going to rewrite number 2 as angle 5 congruent to angle 1. And number 5 here, I'm going to write as angle 1 congruent to angle 7. Do you guys remember the property that says that angle 1 is the middle man there? And I can overlap them like that, and then I can get rid of it and say 5 is congruent to 7. That's the transitive property, okay? So, going off of what Jagger said, we could use the transitive property there, okay? But there's another option here. Looking at just angle 5 and angle 7 to one another, they are what kind of angles? Vertical angles, okay? So we could actually say either a transitive property or vertical angles theorem, okay? Whenever you're talking about vertical angles, you will never use the word definition of vertical angles, okay? That will never be a reason. It's always vertical angles theorem because that's what established their congruency. Okay, so got a lot of facts here, but have we, if I want to say that 1 and 8 are supplementary, how do I know when I look at 2 angles that they are supplementary? Or what is the feature about 2 angles to be able to classify them as supplementary? They add to 180. So somehow, throughout my proof, I've got to get a way to set angle 1 plus angle 8 equals 180, right? Look at this statement right here. Right now, you've got measure of angle 7 plus measure of angle 1 equals 180, right? Okay. Well, if I replace that 7 with 1, that would get me where I need to be, right? Okay. Is there anything in my proof so far that says 1 and 7 are the same thing? Yeah, it says here 1 and 7 are congruent. Now, this is just a formality type thing right now. 1 is a shape. Angle 1 right here is a shape. And angle 7 right here, the way I'm talking about them is that they're shapes, right? These are representing numerical quantities. So I can't replace a shape for a number. Does that make sense? So before I do this, what I'm going to do, I'm going to say step 7 is that measure of angle 1 equals measure of angle 7. And that is the definition of congruency. Whenever you go from congruent to equality or equality to congruent, that's always going to be your reason, definition of congruence. Now, my step 8, I'm going to take this line right there, line 4, and I'm going to rewrite it down here in step 8. But instead of saying measure of angle 7, I've just established that measure of angle 7 is the same thing as measure of angle 1, right? So let's put measure of angle 1 in its spot. And then plus the measure of angle 8 equals 180. Okay, so I replaced that right there, measure of angle 7, with measure of angle 1. What is that when you replace something with what it is equal to? Substitution. All right, then I got a bunch of junk here that is in the way. Okay, so now we have said that 1 plus 8 is 180. So what does that tell you about angle 1 and angle 8? If they sum to give me 180, they must be what kind of angles? Supplementary. And because you said they are, you identified them, you've classified them as supplementary. And the only way that we can classify things is through the use of their definitions, right? By knowing what categories they should fall in. So this reason should be definition of supplementary angles. Okay? Now, as we look at this problem, there's some stuff in there that we didn't necessarily need. There's some stuff in there that wasn't useful. Okay? Did we at any time use this statement here that angle 5 and angle 7 were congruent? Did that help me get to do a replacement here with measure of angle 7 plus measure of angle 8 equals 180 to get the 1 plus 8 equals 180?
Yeah.
The 5 and 7 did?
Yeah. Because then how would you know that 1 and 7 are congruent?
1 and 7 were congruent because they were alternate exterior angles in the picture. Okay, so what I'm trying to get at here is that statement right there, 100% true. 100% true. Nothing wrong with it. Okay, and if I leave it in there, nothing wrong with it because it's true. Does that make sense? Okay, but it wasn't necessary. It wasn't one of those statements that we stitched together to get something new. So if we are viewing these proofs as kind of like a rough draft or an outline, you guys have written rough drafts before, right? For English class? You ever write a rough draft and then when you're writing your final draft, you completely delete a paragraph, completely delete a sentence or something like that? That's what this would be. This would be something that is true, doesn't ruin my proof at all, but it's not necessary. So I could, when I actually formally write this as a paragraph, which we would want to do eventually, and we'll see some of those later on, we would get rid of that statement because it doesn't help our purpose at all. Does that make sense? Now here's something that I want to make kind of a contrasting argument to. What if I would have said angle 5 and instead of saying angle 5 is congruent to angle 7, I said angle 5 is congruent to angle 8. Is there anything in my picture, is there anything in the logic before that step that would lead me to 5 and 8 being congruent? No. So I'm not saying it's wrong, I'm not saying it's false that they're not congruent, but I don't know. I don't have enough information to make that conclusion. So I don't know. That would then be a piece of information that if I left it in there, would make my proof wrong. Does that make sense? Okay. So extra information that is true is okay when you're writing a proof. Okay. Extra information that we can't prove to be true or we can't deduce to be true, that's a problem for our proofs. All right. And the reason I talk about that, and the reason, a lot of times I'll let you guys kind of take I'll ask open-ended questions like, what do you recognize? What do you see? Okay, what relationships exist there? Is because when you're working on your own, that's kind of what you got to ask yourself. Okay, I've got my given down. I've written my vocabulary down. Okay, I've written what the vocabulary means to me. Now I look at my picture. What else is there that I know? And I just try to start writing the true facts that I know. And then hopefully after I write enough of those down, I can start to maybe piece things up together over here and maybe use the transitive property or maybe use substitution, and it will generate something new that'll get me through the proof. Does that make sense? Okay. So if you ever get stuck, the idea is, okay, look at my picture. What else do I know? What is a true fact about what's going on there? And see if I can generate at least a new statement that can help me maybe generate then another one after that. And as far as we need to go with that, we might need to do that 2 times, 3 times, 4 times. But that's the approach with proofs. That's a lot of people say, how do you know how to do these? Well, one, I've been doing this since I was your age. Okay, so how old are you guys? 15, 16. Okay, so I've been doing this for 20 years. Okay, and been teaching it. So if I teach it, I've got a lot better of I've forced myself to have a better understanding of it, right? So I can see these things a lot quicker. This is like day 4 of doing proofs. If you're struggling with it, that's expected. Okay. That being said, if you ever, let's say, does anybody play basketball? Okay, so if I play, has everybody played basketball before or watched basketball? Okay, so I'm playing basketball, and think about like Shaq. You guys old enough to know Shaq? You guys ever watch Shaq play? Does anybody know what Shaq was really bad at? Shooting free throws. Shaq was awful at shooting free throws. He was just, a lot of big guys are bad at shooting free throws. They're just awkward. Okay. They don't have the touch that you need. So do you think Shaq was just like, hey, I suck at free throws. I'm never going to practice a free throw and practice ever again? No. Even though he sucked at free throws, he was probably one of the people that practiced the most shooting free throws, right? Does that make sense? So if you're not good at these, you can't use the avoidance technique and say, I'm never going to work with these. When Mr. Fay talks about it, I'm not going to work, I'm not going to round down because I don't get them, so I'm just going to ignore them. Because if you ignore something that you're not good at, are you ever going to get good at it? No. Okay. So if you're bad at free throws, you stay after class or after practice and you shoot more free throws and shoot more free throws so that when you get in a game, you're going to be successful in shooting those free throws. So if we get on a test and there's a proof on there, we're going to be successful at it. Okay. When the one saving grace about a lot of our proofs, and the state hasn't come down with any final argument yet about what they're going to do for the end of course exam in regards to whether we're going to have it this year or not or whatever. It's still being, litigated or whatever. When they do present proofs on the end of course exam, a lot of them, I won't say all of them, but a lot of them are kind of like this, where they've got some of the things filled in for you, and then you fill in reasons, or they might have everything filled in except for the last statement, or they might have everything filled in and ask you what's wrong with this proof? Why is it not true right now? What's the incorrect statement? There have been times where they've asked people to do the whole thing by themselves and type it all out, and that's a pain in the butt, but those were few and far in between. So that's kind of a saving grace. Let's kind of look at this one, okay? It says, suppose the missing reasons in the 2-column proof, supply the missing reasons in the 2-column proof. Here it just says A is parallel to B, and C is parallel to D, okay? Does anybody know what that shape provides us? If we got, kind of looking at this shape here on the inside. It could be a square, but I don't know enough information yet to actually classify it yet as a square. Say again? Not a trapezoid. You're on the right track, though.
Rhombus.
Or it could be a rhombus.
Square.
It is a quadrilateral because it's got 4 sides. It could be a square.
It's a rectangle.
It could be a rectangle, but what do I need to know about a rectangle, or what do I need to know about to have a square? This is a parallelogram. Okay, now a square is a parallelogram. A rectangle is a parallelogram. I know the word rhombus. Rhombus is a parallelogram. But those are special parallelograms that they have special features that make them those things. Does that make sense? Mm-hmm. What makes a square a square? Okay, all the sides are the same length and 4 right angles. Okay, what makes a rectangle a rectangle? Okay, so the sides are longer. So there's no requirement on how long the sides have to be, but you need 4 right angles, right? So if I ever have to classify a parallelogram as a rectangle or a square or a rhombus, one of the features that we look at is to determine are there right angles or not, because then it'll say, well, then it has to be a rectangle or a square. And then if I can say, well, the side lengths are all the same, that means it's now going to be a square, right? If they're not the same, then it's going to be a rhombus. So that logic is, how do I, and we'll see that later on in, I think, chapter 5. Here's a shape, prove that it's a rhombus, prove that it's a square or a rectangle, and we'll use those types of facts and features to do that. So here we got a parallelogram. We want to prove that angle 1 and angle 3 are congruent. Okay. First thing they say is that A is parallel to B. That's given. Okay. And if I look at lines A and B, so I'm going to just clean things up a little bit. I know you guys can't do this. But if I look at A and B being the two lines that they're referring to, and I look now at angles 2 and 3 that they're talking about in line 2, and I'm trying to get a reason for why 2 and 3 are supplementary. Looking at this picture right now, why would angle 2 and angle 3 be supplementary? What kind of angles are 2 and 3 for that top line and that bottom line? Same side interior. So we got the same side interior. For us, it's a postulate, but if you don't, I don't even care if you just write same side interior are supplementary, or same side interior is fine, but it is in our textbook a postulate. All right, so the next thing that they do then is that they say C and D are parallel. Okay, so we, for the most part, have written our givens all at the beginning. I think that's just a safer thing to do, but it doesn't matter as long as you write your given before you actually use it for another step. It doesn't have to be all in the first line. Does that make sense? Okay, so this feature here, C parallel to D, had no bearing on this blue statement, so it can come after it. Okay, and because it has no bearing, it could come before it as well. So now, if I look at these, why would 1 and 2 be supplementary? They're same side interior again. Okay, now we had a theorem a couple days ago that said something like this. I'm going to take a picture here. I'm going to say angle 3 and angle 2, they are supplementary. You guys agree with that? Okay. I'm going to now take angle 2 again. So 3 and 2, supplementary is coming from that line right there. This line right here, 2 and 1 are supplementary. Well, if I start with angle 2 and angle 1 has to be supplementary to it, angle 1 would have to kind of look like that, wouldn't it? What are you recognizing about angle 2 here and angle 2 there? They're the same, right? So what does that tell me about 1 compared to 3? They have to be the same, correct? Okay, so that logic I think is easy to see or helpful to, maybe you put in like measurements here. If 2 is 30 degrees, then it's got to be 30 degrees down there. If 2 and 3 were supplementary, then that had to be 150. If 2 and 1 were supplementary, that had to be 150. And you see that they're both 150, right? So using maybe specific values helps out with that connection that those 1 and 3 are congruent. The theorem here that we're going to write, and I'm going to type it because it's a lot to write, it's called the congruent supplements theorem, which obviously if you learn that name, that's fine, you can use that, but if I just learn the name, I don't really know anything about it, right? If I just learn your guys' names, but I never have conversations with you in class or outside of class, all I know is your name, and I don't know anything about you, right? So if I just know that name, I really don't know what it's saying. What it says is if two angles are supplements to the same or congruent angles, And in this case, it's to the same because 3 is supplementary to 2 and 1 is supplementary to 2. So 1 and 3 are the two angles, and they are supplements to the same angle, angle 2. Then the two angles are congruent. That's what the congruent supplements theorem says. Okay? If two angles are supplements to the same angle, so for our particular situation, the two angles would be 3 and 1. They are both supplementary to the same angle, angle 2. Therefore, the conclusion is that the two angles we started with, 3 and 1, are congruent to one another. Okay? That's kind of what you're going to see a lot of times with proofs. Would you guys agree that these first 4 steps were pretty easy? Okay. That last one's kind of hard though, right? Generally speaking, that's kind of the approach. That about 90% of your proofs, if you follow the patterns that we've seen in the past, follow that 7-step approach that I gave you previously, you're going to get 90% of your proofs right. It's then that last 10% where you got to think of maybe some obscure theorem that we've used in the past, maybe once or twice, that wraps everything together for us. Okay? No new homework. Finish up that 3-2. Come to class tomorrow with questions over. It'll be due tomorrow night. So if you got any questions over, we can talk about them. But that's it. But cool?